Hey friends, welcome to the carbon story. Carbon is an element available in nature. In fact, carbon containing compounds are called as organic compounds. Carbon is available in different forms in the nature and they are called as allotropes. Carbon is diamond, carbon is graphite, carbon is fullerene, carbon is graphene. The technology which is called as carbon technology we refer nowadays as nanotechnology. Carbon is used in medicines, carbon is used in ornaments, carbon is used in graphite form pencils. So carbon is everywhere. In fact, our body is made up of carbon and all the organic molecules, they are called as carbon containing compound, have different properties, and very famous properties are called as isomerization. So carbon can form different isomers. Apart from that, carbon is very useful in future generation and generating a nanotechnology. So carbon is very useful and it forms a hybrid orbitals. Carbon can be available in different hybridized forms, sp3 hybridized forms, sp2 hybridized form and sp hybridized form, where s orbitals and p orbitals are involved. Carbon is forming a 4 single bonds or a double bond or a triple bond. So carbon is a very famous element in our studies. So let us have a kind of organic chemistry questions today in a very first show. So this is all about a carbon story. Thank you. The show question number 1, level 0, and the question is: organic compounds are the compounds which contain. Options are A, carbon only, B, carbon and hydrogen only, C, carbon and hydrogen, and D, hydrogen only. Dear friends, organic compounds are the compounds which contain both carbon and hydrogen, and apart from that other elements are also present. So option A and option D are incorrect option. When we look at option number B, then it states that it contains only and only carbon and hydrogen, which is also incorrect statement because organic compound contains other elements too. So the correct answer is option C, that is carbon and hydrogen. Now presenting the question number 2, level 0, and the question is: the unique properties of organic compounds are. Option A, isomerization and water solubility. Option B, sublimation and low density. Option C, catenation and isomerization. Option D, catenation and water solubility. Dear friends, organic compounds can carry some unique properties. When we talk about isomerization, then organic compound definitely isomerize to form different organic compounds. When we talk about water solubility is not unique character of organic compound. Some organic compounds are water soluble while the other compounds may not be soluble. When we talk about density may not be unique property because some organic compound may have low density while the other organic compound may have high density. When we talk about catenation, definitely catenation is a kind of property where the element in presenting the organic compound, say for example carbon can join with the other carbon to form long chain, and it is a unique property of carbon and some other elements in the group. Therefore, the two properties which are unique properties for the organic compound, and the two properties are catenation and isomerization. So the correct answer for this question is option number C, that is catenation and isomerization. So correct answer is C. Now presenting the question number 3, level 1, and the question is: carbon is tetravalent and it can form a single bond with an element which is basically option A, univalent only, option B, divalent only, option C, both univalent and divalent, option D, may be any valency. Dear friends, when carbon forms a bond, it can form 4 single bonds and it may form a double bond, it may form a triple bond as well. While it can form a bond with the other element, but it is not necessary that the other element may be univalent only or a divalent only. The element may be any valency or maybe anything. Any element may be connected to the carbon. So the correct option for this question is maybe any valency, and the answer is option number D, that is maybe any valency. Now presenting the question number 4, level 1, that is, in organic molecules, carbon is hybridized and form sp3, sp2 and sp hybridized orbitals. Hybridization is option A, mixing of orbitals and get converted to equivalent orbitals. Option B, mixing of orbitals and get converted to non-equivalent orbitals. Option C, both A and B options applicable. And option D, definition is not true in any case. Dear friends, in this particular question, the question is all about hybridization. In carbon molecules, carbon can get hybridization sp3, sp2 and sp hybridization. When it gets hybridized, it generally mixes the orbitals which are not equivalent. For example, s orbital is spherical and p orbital is dumbbell shape. So when they mix, they are forming an equal shape and equal energy orbitals, and the new orbitals are equivalent. So the correct option for this answer is option A, that is they are mixing together and form equivalent orbitals. So the correct answer is option number A. Now presenting the question number 5, level 2, and the question is, how many sigma and pi bonds are present in but2-ine? Option is 10 sigma bonds and 2 pi bonds. B, 10 sigma bonds and 1 pi bond. C, 9 sigma bonds and 1 pi bond. D, 9 sigma and 2 pi bonds. Dear friends, if you want to get the answer of this question, you need to draw a structure of but2-ine. And the structure of but2-ine is, there are 4 carbon, 1, 2, 3 and 4 carbon, and but2-ine means second position is ine, means there is a triple bond between 2 carbons at second position. Remaining are occupied by the hydrogens. So you can see that this carbon is already tetravalent, all the valencies are fulfilled. Here the third number carbon is already having all the valency fulfilled, and you can write 3 more hydrogen on this terminal carbon. So when we count sigma bond, we need to count bonds like this is 1 sigma, second, third, fourth, any one of these, fifth, sixth, 7, 8, 10, 9. So we have 9 sigma bonds, and we can see that there is a 2 pi bond. So 2 pi bond present as it is the ine molecule. So the correct answer will be 9 sigma and 2 pi bonds. Now presenting the question number 6, level 2, and the question is, orbitals involved in the formation of sigma and pi bonds are respectively option A, both hybridized, option B, hybridized and non-hybridized, C, non-hybridized and hybridized, and D, both non-hybridized. Dear friends, when sigma bond is formed, all the hybridized orbitals are taking part in the bond formation, and when pi bond forms, all the non-hybrid orbitals will take part in the pi bond formation. So the correct answer for this question is hybridized and non-hybridized orbital, and that option is option number B. So the correct answer is option number B, hybridized and non-hybridized orbitals. Now presenting the 7th question of level number 3, and the question is, the molecules with 10 sigma and single pi bonds are cyclobutene and methyl cyclopropane, methylbutene and butene, cyclopropane and cyclobutene, cyclobutene and butane. Dear friends, if you want to solve such kind of question, you need to prepare all the structures and you can easily get the calculation of the sigma bonds and the pi bonds. So let us prepare and understand the question and answer. Such kind of question requires the preparation of structure. So let us prepare the structures of the given compounds in the options. First question, cyclobutene. Cyclobutene is a molecule where a butane is present and we can put double bond at any position, so we can prepare cyclobutene. Well, methyl cyclopropane can be prepared by, as it is a cyclopropane, we have to prepare triangle and propene and one methyl group is present. Methylbutane, so there are 4 carbons in a straight chain with one methyl branch. Butene, so there are 4 carbon in a straight chain and second carbon has double bond. Cyclopropane, a simple structure which you can say also a triangle. Cyclobutane, a simple structure with 4 corners. Cyclobutene, it is similar structure to the option number 1. Butane, simple structure with 4 carbon in a straight chain. In all these structures we have to complete the tetravalency of carbon and we need to count the sigma and pi bonds. Let us find out first of all in the structure number 1. This carbon has 2 hydrogens, so we will show that 2 hydrogens. Similarly, this carbon has 2 hydrogens. The carbon which has only 1 hydrogen, because already double bond present, 1 hydrogen. Similarly, this is the terminal methyl group in the cyclopropane methyl. So there are 3 hydrogens present. There are 2 hydrogens present over this carbon and 1 hydrogen is present over here. So let us count the sigma bonds. So sigma bonds are 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So in this structure you can say 10 sigma bonds are present and 1 pi bond is also present. So 1 pi bond is present. Now coming to the methyl cyclopropene, and we can find the how many sigma bonds and pi bonds. So sigma bonds are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and the 1 pi bond is present. So similarly here also 10 sigma and 1 pi bond is present. So it means that very first option is the correct answer for this question, and similarly we can solve the other structures, the sigma and pi bonds, to justify the answer that the option A is the correct answer. Correct answer is option A, cyclobutene and methyl cyclopropene. Thank you. Crack the 7, we are guiding you add 2 brain points, and today add 2 brain points are number 1 organic compound, number 2 sigma and pi bonds, and number 3 hybridization. So understand these 3 points very clearly and enjoy the session. Thank you.